Hello everybody, welcome to my channel. This is a new blog on the Spark series that we are doing. In this, we will be discussing about partitioning in Spark and how there are three different places where we can control the partitions, and we will see how we can do that and why partitioning plays a key role in Spark. Let's get started. So, to start with, first thing is partitioning in Spark is nothing but a logical chunk of data that is stored in memory by Spark, and one partition is processed by one particular task. So partition is also directly proportional to the parallelism that a Spark job will have. So, for example, if you have one executor with 5 cores and there is a uh, file which is being read, and that file has, let's say, two partitions. So the remaining three blocks, three cores of the executors will sit idle. So if it was possible for that data to be split in 5 partitions, then it will be easier for all those cores to work parallelly on those 5 partitions and then produce a result. So partition plays a very crucial role in deciding the parallelism of the job. And that's where, if we have misconfigured or not proper settings of the partitions, we will see issues like too many partitions. Then we will have slower data reads. If we have too many small partitions, then we are wasting resources. If we have overly large partitions, then it can cause out of memory errors. If we have small number of large partitions, that again means we will have other workers sitting idle. That's where what is called a straggler in terms of distributed computing. In Spark job, we can go ahead and see the event timeline. You will see one executor started and it's doing the all work, and other executors are sitting. Or in this stage view of the history server, you can see in the executors tab, that no, not in the executors tab, in the stages tab, you will see it will say one task out of, let's say, 200 tasks running, or let's say it will say 200 199 tasks complete, and out of 201 task is running. So that those kind of scenarios will come where you will have a slow task taking up wasting the resources of all the other resources which are there. So that's one other thing. And if you have fewer partitions, that may cause spilling to disk and out of memory errors as well. Because few partitions means if the data is, let's say, same, and we have 5 partitions versus 10 partitions, let's say 10 partitions is the equal number, let's say optimal number. Then if we have only 5, then we will be each executor will be processing more data, and that's where it will try to fetch more and more things in memory, and it will cause either disk spill or it may cause an OM error altogether. So yes, in Spark there are different types of partition that come into picture when we are working, and based upon the stages in which that job is, we can see different types of partition that are there. While reading, we have a concept of uh, understanding that how many partitions we will read, and uh, uh, based on that we will create number of tasks, number of jobs. During a shuffle phase, for example, when we are doing a group by operation in a join, or let's say join or a group by operation at that time, and if we have too many number of keys which are there, so it will try to adjust and put those keys. The default number of spark.sql shuffle partition is 200. So if we want to have that, uh, uh, if it is fixed at 200 by default. So if we have very large data, that 200 number might not be sufficient. So we'll have to change that so that we get equal partition or equal distribution of numbers, number of partition that we have that can be processed by the executors or the parallel task that we have. Then again, at the output side also we can decide the partitions, because, for example, each executor does one single write. One single file, right? So if we want if we want write process to get speed up, we can divide that work. Let's say instead of writing 1 GB file, we can say write two files of 512 MB in parallel, or we can say run create four files with 256 MB of data from one executor. So that's a way we control is if we have uh, if we want to reduce the number of partitions, we use coalesce. If we want to increase or decrease with shuffle, we use repartition. Generally, to increase, we will be using repartitioning. And while writing the data, we can decide max records per file. So this max record per file is what decides that each file will contain how many records, and that will distribute the data. For example, let's say if we have 1,000 records, and if we decide if we mention that map max records per file is 100, so automatically it will create 10 files. But if we decide 500, it will create two files. So that way we can handle better strategy of writing the data with either to increase the parallelism or to increase the overall load of the downstream application. For example, let's say if we write 1 GB one file, the next phase that comes out and read out of this data written by our pipeline, their parallelism gets reduced, right? So that way we have to balance between read and write performance based on the partitions that we have. So as we mentioned, input size, we have these configurations that we can decide. Uh, so for example, when we say spark.read, default parallelism decides how many partitions are read in parallel. So that we can handle this as well. Max partition bytes, this decides that how many bytes will be read to create one single partition. So just see a difference. This is max partition bytes and this was max records per file. So these two are two different. One is for the read side, one is for the write side. So while reading, we can decide how a partition will be created. Minimum number of partition number is that okay, uh, this is when a file is there, big file is there, how many minimum splits to be done so that we create multiple files. That decides this one. And there is one open file. This is used. This is basically saying that when you open a file, what is the cost of opening a file? So you assign that to decide on whether you should be creating more number of jobs, more number of partitions, or you should be doing it with one partition itself. The reason is that, for example, let's say reading a file in S3 versus reading a file from disk might be two different scenarios. So in that, if you want, for example, let's say if we can have instead of reading one file multiple times, what if we read it in one and then do the split? So that cost of opening a file is added while it is trying to decide how many partitions we should be creating out of this read file. So that's this setting does that. Generally, it's I think we can for cloud scenarios anywhere like if it is GC, ADLS or S3, it doesn't matter because all three will have same cost. But this will come into play when you have set up between data on-prem and data on cloud, because S3 versus SDFS reads will have different costs involved. So these are the things that we can uh, decide to read. One other thing is that while we are reading from databases, there we can decide how many partitions will be created based on the partition column and their lower and upper bounds. Right, so there are four configurations: partition column, on which column the data will be partitioned, what will be the lower bound, what will be the upper bound, and how many partitions we want. So that way we can control the number of partitions that we see from reading a disk. So this is uh, one another one aspect of creating partitions while we are reading the data. Then we have uh, partitioning scheme when we do a shuffle. As we know, when we do a group by or when we do any other kind of operations that creates different number of different shuffles. That time it will decide on what should be the number of files, number of partitions that will come after that shuffle has happened. So that also will set some certain partitions. As I mentioned, this is one which is for join or reduce by key or parallelize. This is default set to 200. We can change it to whatever number we want. Generally, we should be doing based on the keys that we are doing the shuffle on. So if we are doing group by, so that we know how many group by unique combinations will come. Based on that, we can decide how many partitions we should have down the line. Then there are, let's say if we have certain numbers of partitions already there, but we want to improve the process or we want to reorganize the data. At that time, we can say repartition. It is a function in it's a not a function, it's a transformation that is available to Spark. You can use a repartition to change the number of partitions which are there in Spark data frame. So repartition, if we simply give a number of partitions, let's say we say df dot repartition and we'll say 10. So that data frame will be repartitioned into 10 partitions now. It will use a round robin partitioning, and generally it creates balanced partitions. There is the chances of skew happening in these partitions are very less. There is another one which is repartition based on the partition expression. Here, if you mention the partition expression, it will try to create a hash out of it. In this case, the chances of happening, the chances of skew is high because it might happen that certain hash values are getting calculated again and again. Sorry, the hash values are getting emitted by the function again and again. That time we might have skewed partitions. Then we have repartition by range. That basically tells us to do based on the range. Again, this will create it will create something somewhere in between hash and round robin partitioning schemes based on the balance wise. So it will create slightly balanced uh, partitions. Uh, if we want to decrease the number of partitions, we can use coalesce, which simply reduces the number of partitions which are there. So I will create a separate blog on how coalesce does this uh, reduces the number of partitions without doing a full shuffle, and that's why this is generally preferred if you are using uh, if you are trying to reduce the number of partitions. But again, I am saying it is not always recommended to use coalesce to reduce the partition because there is one it's that if you this is coalesce is your last statement just before the write, it makes sense. But if after doing coalesce, if you are doing something else on that data set, generally coalesce is not recommended. The reason being because there is no shuffle, there is no AQE will come into picture. So AQE can't optimize coalesce. So that's why. So we generally it's not a blindly. We should not say that okay, if we have to reduce the number of partitions, we will use coalesce. So that is something for next video we will see. Uh, then this was all about partitioning that we are doing, and there are some repartition that happens on AQE level, which also does certain repartitioning of data. So if we have AQE enabled, we can say that okay, skew join, and then we say what is the partition factor, what is the partition threshold, coalesce partition enabled. So this what basically we are with these configuration what we are saying to AQ is that okay, when you are trying to do a repartition, use these pointers or these guardrails like what should be the initial partition number when you are doing the coalesce. So if you are, let's say you are reducing from 1000, can you directly go to from 1000 to 1? No. So you if you want that okay, at least 10 number of partitions should be there. So you say initial partition number will be 10, right? Then you have partition size in bytes. You say, okay, when you are doing a coalesce or a repartition, so during that, what should be the size of each partitions? So that kind of guardrail this provides so that AQE can, while it is creating new partitions, it adheres to those guardrails. Then other other side aspect where we get partitions is while we are writing data to file systems. There also we can do before writing that we can do some strategies that controls how many files will be written. For example, one is partition by. So let's say we have a data set which is which has, let's say, on a particular column it has, let's say, 10 values, 10 unique values, and we want that okay, each of those values should go into one file. For example, it might be happening that let's take an example of each file contains some data about a country. So we can say partition by country, and then it will create one file for each country. Again, we might have an what do you call a scenario where countries with having large population or if the data is related to linked to the population, countries having large population will always have an skew. So to control that, we can also say, okay, number of record that in each file will have. So partition by, and then we provide a maximum records per file. Then it will say if we have said the 10, let's say we say 1 million records per file. So if for certain key, if we have 10 million records, then it, because of the size that we have, the records number that we have mentioned, it will create 10 files for that. So that still will be, we will be able to read one individual file. When we read, it will read always the equal number of records. So that is, this is very important. We should always pay attention to the max records per file option that limits how many data will be written. Uh, this is one example where we are repartitioning based on the columns, and then we partition by, and then we save. So this is repartition by while doing in memory. This is write dot partition, but this is while we are writing to the disk, and this is save mode. So here is one example that partition by method does not trigger install because it's generate too many files. It's 200. Let's say if we have 200 partitions and then we do a partition data by date. Say if we have 365 files in each, leads to 365 into 73,000 files. Why? So the example that is given in here is that first of all, when we do so in this case, let's say this was partitioned by date. Sorry, this was partitioned by, let's say, anything. Let's say we did a join. So last operation that happened on the DF was join, and we had default number of shuffle partition was set to 200. So at that time, when we say write and partition by that column, let's say any column, in which case we are saying date. So it will create 200 into, so the already DF partition into write, then we do partition by, this will create too many files. So we have to balance if we are using both in combination, that okay, before doing this, what we should be the right approach or right number of files we calculate, and then only we do the right part repartition as well as partition by. And this one, if you see, which says that okay, we have option of doing a bucket by. So bucket by is again something which is similar to what we had seen earlier. Number of files in bucketing will be partitions into the number of buckets. So let's say we want 12 buckets based on this key column. So what will happen? Number of bucket is 12. So here we have given 12, and let's say this DF had, let's say, 200 partitions, then it will have 1200 into 12. So that many files will be written. So these things we have to understand before we try to make the partition size suit our required expected partitioning scheme. And also we can do a coalesce while doing a bucketing, which we mentioned in here while writing. We can do a coalesce as well if it has lower number of partitions. So this is it about all things that I wanted to talk about in partitions. So with after this, if someone asks any question about partitioning, so you understand how the partitioning are decided when you are reading from source while you are doing some transformation, and then how many numbers gets calculated, and then where we are trying to write to a disk. So there are three stages in which partitioning comes into picture, and we have three different approaches to handle that. So that's it for this. Have a nice day.